In this video, we're going to be graphing exponential functions in transformational form and also exponential functions that have the base of e. So if we look at the Algebra 2 with Statistics big picture, this is covered in the second 9 weeks, and it is actually day 3 of Unit 5. So students will have already been introduced to exponential functions in Algebra 1 and also in the first 2 days of this unit. Looking at the scope and sequence, we can see the standards that this will cover. It is standard 16, standard 17, standard 18, and standard 20. And most of these deal with the functions, the key features of those functions, and transformations. One thing that I wanted to point out on the teacher note that is also on the scope and sequence is that we want to look at the 3 points for each of these graphs. So when x is -1, we're always going to get the y value 1 over the base for the parent function. When x is 0, we'll get +1, and when x is 1, we'll get whatever the base is. So once we apply the transformations, we're actually going to be shifting those 3 points of interest. So as we look at the lesson, you're going to see that we have 3 different parent functions, y equals 2 to the x, 3 to the x, and then we have our e to the x. It says graph on the graphing calculator, but it's pretty simple to just set up a table of values, and we can actually plug each of those x values into our function. So when I look at my first function, which is y equals 2 to the x, really just need to plug in those x values. So if I evaluate the function at -1, this might throw some kids off. 2 to the -1. A lot of them forget the exponent rules. And so this would be a good time to review that this is really going to be 1 over 2 to the +1, or 1/2. When we plug in 0, we're going to get 2 to the 0 is +1. And then we have 2 to the first, which is +2. So that's why on the teacher note, we're seeing that 1 over the base, where my base is 2, is going to be the y value at -1. We had 0, 1, and then also 1 comma the base. So once we plot those points over here, we have the 3 points that make up that exponential function, and then we can connect all those. Now, if we go ahead and graph the 3 to the x next, we're going to have a similar table of values. We might could go a little faster on this one. So we know that the base is 3. So when I plug in -1, I'm going to get 1/3. Plug in 0, you get +1. And when you plug in 1, you get 3. So kids could always check these on a calculator, but setting up the table of values is helpful to see the similarities between each of these functions. So when I graph those, I have -1, 1/3, 0, 1, and then 1, I'll go up to +3. Okay, and the final graph is going to be our exponential function, y equals e to the x. So what I would encourage kids to do is find e on the calculator, and we know that this base of e is approximately 2.71828. I'm going to write 2.7 here for short. And this is used in a lot of application problems where things grow or decay continuously. So kids have probably seen this in some of their science classes as well. So when we plug in -1, we're going to get 1 over the base of e. And so plugging that into the calculator, that's approximately 0.37, we round. So for graphing purposes, the decimal is easier. We're going to get e to the 0, which is +1, and e to the first is e. So that's where we're going to estimate with about 2.7. So same thing, we're going to plot those points. And then 1, 2, and about 2.7 is going to give us our last graph. So now that we have these 3 parent functions, the rest of the lesson is going to use those, but we're going to apply the transformations. So, if you had colored pencils, a great idea would be to graph the parent function and then in a separate color, graph the transformation. But we can see here that our first equation is 2 to the x plus 1. And because the +1 is actually inside the function or connected to the variable, we know that this is actually going to move left by 1 unit. So since my base is 2, which is going to match my first parent function that I have in green, we're going to actually move those 3 points to the left by 1 unit. So I'm going to go ahead and draw the parent function that we have. And then we're going to just transform that. So here's my parent function. And in a separate color, I'm going to move each of those to the left by 1 unit. And that would be the transform graph. This lesson would also be a great way to work in domain and range and to determine which transformations affect the domain and range for these exponential graphs. So now it's your turn to practice on the remaining questions 2 through 6.